All right, so getting ready 11. We are going to start with using substitution to find some values. Now these are the values that we're supposed to substitute are given to us in function notation. So when it says find f of 1, f of 2, and f of 3, that means we're going to put the 1, the 2, and the 3 into our equation for x and just see what we get. So one at a time, f of 1 means replace the x with a 1, so 2 to the first, that's 2. F of 2 means we replace the x with a 2, so 2 squared, that's 4. So f of 2 is 4. And then f of 3 means plug in a 3 in our equation, so 2 to the third is 8. Number 2, same kind of equation, same directions. We're going to find f of 1, 2, and 3, but now our equation is 3 to the x power instead of 2 to the x. So f of 1 is 3 to the first, or 3. F of 2 is 3 squared, which is 9. And f of 3 is 3 to the third, or 27. Number 3, now this equation has some extra parentheses. It almost looks like it's a recursive equation because of the x minus 1. It is not. Recursive would have to say f of x equals f of x minus 1. This is just parentheses like distributive property in our equation. So f of 1 means we plug a 1 in here where the x is. So 2 times 1 minus 1 plus 3. Order of operations tells us to start in the parentheses. 1 minus 1 is 0. So that's 2 times 0 plus 3. Multiplication before addition, so that's 0 plus 3, which is 3. So f of 1 is 3. Same idea with 2. F of 2 is going to be 2 times, we replace the x in the equation with a 2, so 2 minus 1 plus 3. Start inside the parentheses. 2 minus 1 is 1. Multiplication before we add, so 2 plus 3, and that is 5. Therefore, f of 2 is 5. Okay, we're going to complete these tables, but we'll first have to identify what's the pattern in each one. So in this first one, we're multiplying by 2, but multiply by 2. So 32 times 2 gives us 64. Times 2 again is 128. Times 2 again is 256. So that one is an exponential function or pattern. Next one, from 66 to 50, that goes down 16. From 50 to 34, down 16. So this one is linear. It's decreasing by a constant rate of change, is negative 16. So this puts us at 2. Subtract another 16 is negative 14. Subtract another 16 is negative 30. And one more time gives us negative 46. Now, the third table here goes up, then it goes back down, and then back up. So the only way you can alternate from negative to positive is if you're multiplying by a negative number. So that gives us the hint here that this is a geometric sequence. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Times negative 3 is the positive 81. So if I continue this, 81 times negative 3 is negative 243. That multiplied by negative 3 is positive 729. That times negative 3 is negative 2,187. And then the negative 2,187 times negative 3 is positive 6,561. Okay, next one down the list here. I'm going down 80, but then down 40, then down 20. So it's not a common difference, not a constant rate of change. Let's see, can I multiply by something? Well, to multiply and have this number decrease, it must be multiplied, if it's a exponential function at all, it must be multiplying by a decimal or a fraction smaller than 1. So 80 is half of 160, that's multiplying by half. 80 times a half is 40, times a half is 20, and so on. So our pattern is to multiply by 1/2. So 10, 5, 2.5, 1.25. And last one, it first looks like it goes down, but it's not. From -9 to -2 is actually an increase of 7. Then -2 to 5 is up 7. Up another 7 gets 12. So continue adding 7 will be 19, 26, 33, end with 40. Okay, now our tables are actually going to have some kind of meaning. So rather than have the first few filled out for us and we figure out the pattern is going to be given to us in words. So it says I spend $600 to start my business, and it cost me $5 to make each birdhouse. So if I make one birdhouse, what was my total cost to build? Now, it's not $5. I spent $5 on that birdhouse, but I already spent $600 to start my business. So I spent $605. If I build another birdhouse, it costs another $5. Now it's $610. Third one is another $5, $615. So what we do is we add $5 for every birdhouse, but we had to start with $605 because we had that starting amount of $600 to include. So $620, $625, $630, $635. Since that is a linear pattern, we could quite easily make the equation. It's y equals the 5x for the cost of each birdhouse plus, now the y-intercept, the starting amount, was the $600. And that's why the cost for one birdhouse, 5 times 1 is 5, plus 600 is 605. Number 6, we borrow 500 from a relative, and we're going to pay that back at a rate of $15 per month. So this one, my debt starts as a large number and goes down. As I pay back the relative, it's decreasing. So after 1 month, again, it's not 15 or -15. I started off owing $500, but then after 1 month, I paid off $15. So that gives me $485 after 1 month. Subtract another 15 for the second month. I'm at $470, $455, $440, $425. Keep subtracting 15, $410, $395. And since this is linear, I could again make the equation. It would be y equals, since my rate of change is to decrease $15 every month, I had -15 times months X, plus the starting amount was the 500. My debt started at $500. Number 7, you earn $10 per week. Well, after 1 week, I would have $10 because this did not include anything else about how much money I might have had to begin with. So 2 weeks, $20, 3 weeks, $30, 4 weeks, $40, $50, $60, and $70. So that is once again linear since we're adding a constant rate of change, 10. But when I make my equation, it will be y equals the 10 for my constant rate of change times x, but I don't need a y-intercept, or my y-intercept is actually there, it's 0, because I didn't start with any money. And number 8, saving for a bike, I can save $10 per week. I already have 25. So after 1 week of saving, the amount I would have is the 25 that I originally started with plus 10 more. So after 1 week, I have $35. Second week, I save another 10, I'm at 45. Save another 10, I'm at 55, 65, 75, 85, 95. So again, it's linear, constant rate of change is 10, so y equals 10x plus Now my 0th term, my starting amount was the $25 I had before I started saving for the bike.